We are live, you can start, sir.
All right, so welcome to everyone. Welcome to the Gate Academy channel, my dear. So, my dear, in this session, this is the third session of the series of fluid mechanics quizzes with timer, right? So, this is the third session in this series of the quizzes of fluid mechanics, right? So, in this session, as of the previous sessions, we have till yet done two live sessions. We have till yet done two live sessions. We have till yet done two live sessions for fluid mechanics, and now this is the third live session for the same. Okay, this is the third live session for the same. So before I start with this, I would like to request you all. I would like to request you all to like and subscribe the channel. To like and subscribe the channel. If you have not yet liked and subscribed the channel, please, before we start with the quiz, please like and subscribe the channel so that you get the notification of all the upcoming activities. So we are here providing you with the quizzes, with the content section, with the content also we are providing you, right, my dear? So let us share this. Good evening, very good evening, my dear. So let us also share this to our friends so that more students can come and take the benefit out of it. Okay, so let us start with the quiz now, right? Let us start with the quiz now. All right, so first of all, before beginning, let's go through the instruction. So the first things are how to play the quiz, how we can play the quiz. So you can see a link there. You can see a link there provided to you. So you have to log into this link, right, beta? You have to join this link. So how we can do it, sir? So if you are watching me on the mobile, you can do it on laptop if you have one. If you are having a laptop, you can log in into the mobile also. If you are having only laptop, you can switch through Windows, right? You can switch through Windows, okay? And if you do not have the laptop, you can do the split screen function that is there in the mobiles, right? Right. So first of all, when you go to this link, you have to write your name. So the request is that you write your real name here. Okay. Okay. So in this quiz, we do not have any negative marking, right? No negative marking with any question, right? So every question will have some pointers. Okay. A range of point will be there, like from 50 to 100, from 75 to 150, right? Obviously, tougher the question, more will be the points. And why is the range of that point? Because in this quiz, we are going to have points with respect to time also. So if we answer in less time, we'll get the more points. So faster we answer, higher will be the score. Higher will be the score. So see why we are doing this, because see, in the examination, in any competitive examination, like GATE or any other examination you are trying for, this is very important that you do the question correctly also, and you do it in a given time limit, right? Obviously, there is a time limit in all the competitive examinations. So again, I'm requesting you guys to join through the link provided here, okay, so that we can start with the quiz. Okay, so let's join it. So this is how many of you have joined. If any of you have not joined yet, please join the quiz, beta. Please join the quiz. So we have Kunal with us. We have Keshav with us, right? So let's begin with this quiz, right? Let's begin with this quiz. So here we go. The first question. This is a MCQ question, multiple choice question. Okay. So you have to select any one option out of it. Right, but you have to select any one right answer. So we know in our GATE examination, we have MCQ questions coming, right? So we have to solve it and we have to give the options, right? The sooner you answer, more points you will get, okay? Okay, and also I would say that you must answer all the questions, right? But you must try to answer all the questions, okay? So this is a question of dynamics, a classical question of dynamics topic, right? And we have a manometer attached in it. So we know the manometers are used to find the pressure difference between 2 points in terms of head of liquid. So whenever we have manometer, we can have pressure head difference calculated. Okay, so I hope we have seen these kind of questions. Okay, in GATE also this kind of questions are coming a lot, right? GATE में भी बहुत सारे इस प्रकार के क्वेश्चन हमको देखने को आते हैं. So every one of you have answered, but I have got one wrong answer. एक आंसर गलत आया है. Let's see. Oh my god. So just let's see the leaderboard. Oh my god. So basically, just one more click I have made. So I don't know who have given the right answer. So after this question, we'll see. Let's do this question. We have 3 minutes for it. So this is a numerical ability question. This is the numerical ability question. And in this question, we have to see how much percentage of water is spilled out, right? Again, our dynamics, kinematics combined situation, right? So it is a dynamics, kinematics combined problem, right, my dear? What is the topic? Vortex motion. So any one of you who have not joined yet can please join the session. Right, my dear? So 2 of you have answered. This is the standard case also. So what is vortex motion? So whenever we make the liquid to have the bulk rotation about some axis through some external torque. Right, so if we apply some external power source, external torque, and make the fluid rotated about some axis, this is what we call as the vortex motion, right? So in this, we have a container, we have water in that container, and we are making this water to rotate about a central axis, right? Now, when we make this rotated about the central axis, definitely, I think all of us can think of this, that some water will get spilled out, right? And this is happening in a way that the A point you see on the container have the atmospheric pressure, right? You have to tell what is the percentage of water being spilled out. So we do these kind of questions in dynamics, right? Force vortex motion. So now everyone has answered. So all of you have given the incorrect answer in this question, my dear. Right? So Keshav, you have given the answer to the first question correctly. So you have 86 points attained from the first question. And Kunal and Harsha, my dear, you were not able to answer the previous question, this question as well. So, but nothing to be worried about. See, the purpose of this quiz is whether we are doing the question correctly or not, we must try. Okay. And we must try to realize that why we were not able to do it. So when we end this quiz, okay, when we see 4 questions are there, 2 questions are done. So after we complete the quiz, after we go through all the questions, definitely we are going to have the solutions of them, right? So here we go, the third question, and I want all of you to try it correctly. So this is a numerical data question. You have to write the numerical value, okay? Okay. So read the question, see, to solve the question, first of all, read it. And if some assumptions are required, you can have some assumptions also, right? You can have some assumptions also. So in this case, we can see 2 pipes, 2 containers are being connected by the pipe in series arrangement, right, beta? So 2 reservoirs are there, they are being connected by the pipe in series arrangement. Pipe in series is what? So different diameter, different lengths of pipes are attached one after the other. This is what we call as the pipe in series arrangement, right, beta? Now, what we want to do in this question and what is asked in this question, so we want to replace this whole pipe in series arrangement with a pipe of some diameter and some length. So we want it to be replaced by a single diameter pipe whose length is given to you as 1700 meter. Now what we want, so we want to replace this whole arrangement by a single diameter pipe of 1700 meter length. So you have to tell what should be the dia of it, right? Now, obviously, when we are changing the diameter and the length is remaining the same. Okay, definitely we have to keep some parameters constant, right? We have to keep some parameters constant also. Yes or no? We have to keep some parameters constant also. Right or wrong, my dear? Okay, so keeping the other things unchanged, we have to find the diameter. All right, so please answer. None of you have answered me yet. It's not that difficult question. Okay, I give you a hint also. Like what when we have seen this question, what we have seen when we see such concept. Okay, so everyone has answered. All right, so you have answered 371. So I think your answer is very near. So might be some integer mistake, right? So I am accepting that answer, Keshav. Right, I am accepting that. Okay, so let's move. So Keshav, you have given the right answer because like when we have some range, okay, to the next integer. So I accepted that. So Keshav, this is the second question. You have done it correctly, and I think Kunal and Harsha, some internet issue happened, and some of you was not there, right? So this is a dispute. This was a diffuse pipe equation, no? This was a diffuse pipe equation question, equivalent pipe, right? So whenever we can have a pipe in series or parallel arrangement, we can replace it by a pipe of single diameter and length by applying the diffuse pipe equation or equivalent pipe equation. I hope it is fine to everyone. I hope it is fine to everyone. Now moving to the next question and the last question. I am hoping that all of us can give the answer to it correctly. Please go for it. This is the MSQ question. So in this question, we have to choose multiple options, right? So in this question, more than one option is correct. In this question, more than one option is correct. In this question, more than one option is correct. Please go for it. Please go for it. Very simple question it is. We can do it. We know the concept. Okay, so when we know that the pipe, when a flow of liquid is flowing through the pipe, when flow is flowing through the pipe, when there is a fluid flowing through the pipe, there is some power transmission associated with it. Now here what is given in the question that the power that is getting transmitted is the maximum one, right? Now you have to apply the concept you have learned for this maximum power. So when the power transmitted by the pipe is maximum, what are the conditions? Do you remember that? Do we remember it? I hope all of us remember that. I hope all of us do remember that. Right, my dear? Please go for it. Let us see if we can do it or not. So two of you have answered already. Two of you have answered already. Please answer. Rest of you also try to answer this. Rest of you are also try to answer this. So three of you have now answered, my dear. 39 seconds remaining only. 39 seconds are remaining only. I am hoping that we all can do it, but there is nothing tough in that question. Please, rest of you also try to answer it. 28 seconds are left. Just simply using the concept of power transmission, maximum power transmission through pipes. Please answer, my dear. Please answer. I am expecting correct answer from you guys. Very simple question. Only few seconds are remaining. All right, the time is up now. So let us see how many of you have given the right answer. So, Keshav, very good. Very good. So, Keshav, you have answered correctly for 3 questions here. Very nice. Right, my dear? And the rest of you also tried, I hope. And now when we see the solution, we'll try to understand what mistake we have done. So, but there is nothing to be worried about. See, we have to give the right answer in the gate examination. All of this is because of that. So when we are doing it here, my dear, so we are trying to solve it. Okay, so when we are trying to solve it, mistake may happen, but the thing is, we must not make mistake in the gate examination. That is the ultimate target, right? The ultimate target is like that. All right, beta. So now let us see the solutions of this, and let's try to realize what mistake we have done, right, beta? So I'm hoping we can see. Okay, Pankaj. Okay, beta. Now we'll see. So I hope we can see the OneNote now, right, my dear? I hope we can see the OneNote screen now, right? Okay. So now let us start with the very first question. Okay. So some of you were unable to answer this one. So in this question, what we got, beta? We have this x. We have this x given to us, okay, and we have to find this x. So what is the formula? Direct formula we can use. H is equal to Sm by x, Sm by s minus 1, right? But this is the direct formula we had, where H is the pressure head difference between 1 and 2. So let us consider this 1, let us consider this 2. So H is the pressure head difference between 1 and 2 in terms of the liquid flowing through the pipe. So basically, what is this pressure difference? 100 minus 80 upon rho g. Okay, into 10 to the power 3. Right, because the fluid flowing in the liquid is water. So we know P is equal to rho gh. So from there, we can get our H na, pressure head difference in terms of liquid flowing through the pipe. So basically, this is this X we have to calculate. Sm is 13.8 divided by S. S is your 1 minus 1. Right, beta? Right, beta? So from here, when we calculate, we are getting somewhere near 0.1599 meters. Are we getting that or not? I hope we are getting that. Okay. So 20 into, let's check that, 20 into 10 to the power 3 divided by 1000 into 9.81 into 12.8. So we have 0.1592. Okay, nearly this. So this is answer to be given in centimeters. So if I convert it into centimeter, we'll be getting 16 centimeters approximately. So the answer is A. Right, the answer is A. Now, any of you have made mistake here? Can you tell me what is the mistake you have done? Can you please tell me what is the mistake we have done in this question? Some of you have were not able to answer it correctly. Can you please tell me what is the mistake? So we see this kind of a question a lot in the previous year gate also, right? So I am expecting this is clear now. Now moving to the next question. I think none of you have answered it correctly. So let's discuss this one. So water is filled in the cylindrical container up to the top, right? It is rotated about the central axis with angular velocity omega in such a way that pressure at point A becomes atmospheric, right? Pressure at point A becomes atmospheric. The percentage of water is spilled out. So we are rotating it by a velocity of omega. Now, when we rotate it with the velocity of omega, do all of us realize that when such situation happen, when in force vertex, so this liquid will form a parabolic surface. Always it forms parabolic surface, and if the pressure at A is becoming atmospheric, so it can only happen when there is no liquid on this above this point A. So this is how the parabolic should form. Please answer me, is it a yes or no? Is it clear up to this point? See, what we know that whenever a liquid is rotated in a container, a paraboloid surface of water is formed. Right, beta? Right, now they are saying that in such a way that pressure at point A becomes atmospheric. So point A, the pressure will become atmospheric only when there is no liquid above it. Okay, so we have no other way to make the paraboloid like this, right? So that means the height of the paraboloid and height of the container is same. I hope you now must be remembering one standard case, right, beta? So now what is the volume of liquid left in container? What is volume of liquid left in container? How much volume of liquid is left there inside the container? So what is the volume of liquid left inside the container? So now we know this is volume of container minus volume of paraboloid. So in general, we have this now, volume of container minus volume of paraboloid. Volume of container minus volume of paraboloid, right, beta? Right, beta? So what is this volume of container? It is pi r square h minus volume of paraboloid, that is half the volume of circumscribed cylinder. So pi r square z by 2, pi r square z by 2, pi r square z by 2. So what is the z in this case? This z is equal to the height of the paraboloid. So it is pi r square h minus pi r square h by 2. So what is the volume of liquid left? It is pi r square h by 2, right? So pi r square h is the initial volume, and now we are left with pi r square h by 2. So that means half of the water is spilled out. Please say yes or no on that. That means half of the water is spilled out. Is it okay to everyone or not? Please answer me. Initial volume was pi r square h, and now the volume left is pi r square h by 2. So that means 50% of the water is spilled out. Right, beta? Right, Keshav? How Z is equal to h? So, beta, when the pressure at A point should be atmospheric. So you tell me. So what is the pressure on my hand? What is the pressure on this surface of my hand? It is atmospheric, right? Now, if I put some water, if I keep some water over my hand, the pressure on my hand surface would not be atmospheric anymore. Atmospheric pressure on some point means there is no liquid over it. Do you agree to it or not? Only air. So for atmospheric pressure to be on A, so for atmospheric pressure on A, the paraboloid should be formed in a way that the pressure, there is no liquid on the surface of A, on the point above A, right, beta? Right. And we also know that always when we make rotation, we always end up with a paraboloid. Now, if any other paraboloid is formed, the pressure at A point would not be atmospheric. Is it fine to you guys or not? Please answer me. Right, beta? Right, beta? Okay, so pressure being here atmospheric. So this is a standard case. If you remember, in the classes also we have seen this. I know you are my student only. Okay, in classes also we have seen a standard case when half of the water is spilled out. Remember, beta? So when half of the water is spilled out, the pressure at A point becomes atmospheric. I hope it is fine to you. Okay. Okay. Right. Now moving to this third question. So all of you understood this question, second one? All of you understood this question, second one? Please answer me. Please answer me. Is this clear to everyone? Please answer me that, beta. Yahan tak, up to this point it is clear. Now can we move to the third question? All right. So if the pipe in series arrangement is to be replaced by a single pipe of 1700 meter, the diameter of single pipe should be round off to the next integer value. Right, beta? So what can be done here? What can we do here? So we have three pipes connected in series. So we want to replace it by a pipe of single diameter and length. So what is the governing equation, beta? What is the governing equation? So we know, so if the equivalent pipe length I consider L equivalent, so D equivalent to the power 5. This is what we know as diffuse pipe equation, right? We read it in fluid mechanics pipe flow section. Yes or no? This is your diffuse pipe equation for pipe in series arrangement, right? So simply we have to apply. If we know this formula, we can directly apply it. Or if we don't know it, we can derive it also for keeping the head loss HF to be same in the equivalent pipe as well as in the pipe series, and discharge to be same. So considering or making both of them same, and if we deal with the basic formulas, we'll end up with this equation, right? We'll end up with this equation. So what we can do, we can put the length, so it is to be replaced by a length of 1700 meter. D equivalent we have to find. So this L1 is this L1 is this L1 is this L1 is our 500. So let's no, sorry, this is 800. This is 800. So let's convert it into meters. So 0.5 to the power 5 plus L2. This is 500 meters. So what is the diameter? This is 0.4 to the power 5. And L3 it is 400 meters. So let's write is 0.3 to the power 5. Now from this equation we have only one variable left with us, that is D equivalent, and we calculated. When we calculate it, so we'll be getting answer nearly 368 to 375, right? So whatever you get here, you will get in meter. Do not forget to change it in mm, right beta? Right beta? So I hope this question is also clear. Say yes or no. Is this question clear? Please answer me yes or no. Is this question clear? Yes or no, please tell me. Simple question, no? So those who are unable to solve it correctly, are you realizing the mistake what you have done, beta? So all these concepts we normally see, but the thing is when is the right time to apply it, right, beta? Now in the last question we had the maximum power that can be transmitted through pipe is 750 kilowatts. So this is what they are saying, maximum power, right? So what is the condition of maximum power? So this is your H. So HF is H by 3. This is the condition of maximum power as we know it. So what should be the HF? It should be 120 by 3, that is 40 meters. So A option is correct directly. Now they are asking you, so A is correct, B cannot be correct. Now they are asking you the discharge. So we know the power transmitted is rho GQ H minus HF. This is your general formula of finding the power, right beta? So what is this power given? 750 kilowatt, right? Rho is 1000. Let us consider G to be 10 because options are very much differentiated. So even if we write 10 also, we'll get a near answer, right? To save time, we do this kind of a thing. Now H minus HF, it is 120 minus 40, right? So from here we can get the discharge, right beta? From here we can solve for the discharge. Agreed or not? Agreed or not? Okay, so what is the discharge at maximum power condition? Right, so we can put it here, we can find, so we'll be getting somewhere near 0.9375 meter cube per second. So we know to change meter cube per second into liter, we must multiply 10 to the power 3. So the answer is 937.5 liters per second. So I hope it is fine to all of you. Is it fine to all of you now? Right. So no big concepts are getting applied. These all are the general concepts that we use. So I hope that you realize whatever mistakes you have done in the questions. Do we realize it or not? Any doubt, you may feel free to ask me. If there is a doubt, please feel free to ask me that. If we got a doubt, please feel free to ask me that, beta. Do we have a doubt, my dear? So I am hoping you guys have liked the session. I am hoping you found this session useful for you. I am hoping that you are able to realize that where you are lagging behind and what is the things you need to focus more during your revision. These all are the purposes of these sessions, right? So beta, I'm hoping to see you in the next quiz session also. So for the days and the notification, syllabus, everything, please do not forget to like and subscribe the channel. Please subscribe it so that you get the notification also. So the next quiz we are going to have on 22nd on July on the same timing, right? And in that, the syllabus would be boundary layer theory and dimensional analysis. Okay, beta. So we can brush them up and we'll see whether we are able to do the questions within the time limit provided to us. So with this, thank you very much. Thank you very much. And thank you for watching the video. Please do not forget to like and subscribe the channel. If you have any suggestion for us, you can write to us at the email ID you see on the screen. You can call us for or mail us regarding any inquiry of the batches running in the center, right beta? Online classes are running, right beta? Offline sessions are also mostly in some places are started, right? So I am hoping that this is fine to all of you. So please do not forget to like and subscribe, and thank you very, very much. We'll see you in the next quiz.